class or not, if you're upset by that, turn it in tomorrow. Okay? You get an extra day just for grace, but it's got to be turned in by Friday, the end of the day. Okay. Now, get out your purple sheets. You're going to need them unless you memorized what you were supposed to memorize. So we're on 4.2. We're looking at problem number 1. Got a nice little right triangle here. And we're going to find the values of all 6 trig functions. Sine, cosine, tangent, cosecant, secant, and tangent. Cotangent. Okay? Yes?
I don't think some of us have that paper.
Well, I don't know. There's a bin back there. If there's any extras, they're in there. Otherwise, you have to print it from school again.
Oh, yeah.
Make sure you're in the bin that says academic on it. Okay. Now, the placement of this angle, which I don't have a choice, that's the angle drawn in the picture, right? The placement of that angle is very important because wherever that angle is, that determines which sides are opposite, adjacent, and of course the hypotenuse is the hypotenuse regardless. But the side across from the angle is called the opposite side, and the side next to the angle is called the adjacent side. All right, guys, now listen. If that angle were up here, if theta were up here, then this would be the opposite, and that would be the adjacent. So you really have to pay attention to where your angle is that you're working with. Okay, now, I can't remember on your paper if I wrote down, it doesn't look like I did. I like SOHCAHTOA as kind of a mnemonic device. Have you heard of that before, SOHCAHTOA? So you know what sine, or you know what S stands for? Sine, cosine, tangent. And then the O's, the A's, and the H's are opposite, hypotenuse, and adjacent. So these are fractions. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Your trig functions are always fractions. Okay? Well, on the calculator they come out decimals, but decimals are fractions. Alrighty? Now, take a look at your picture. I think there's something missing.
Yeah.
What?
Yes, the adjacent.
Yeah, I don't know what the adjacent side is. So before I can start filling all these in, I need to find the adjacent side, right? How do you suggest I do that? Pythagorean theorem. So be careful. That's the hypotenuse. So 2 squared plus b squared, I don't care what you call this, equals 5 squared. Everybody got that? The 5 is the hypotenuse, so it's got to be over there by itself. It's c squared. All right, so it looks like b squared is going to be what, 21? Did you get root 21?
Yeah.
So now, using SOHCAHTOA and your purple sheet, whatever you want to do, you can fill all these in. Sine is opposite over hypotenuse, so 2 over 5. Cosine is adjacent over hypotenuse, so root 21 over 5. And tangent is opposite over adjacent, so 2 over root 21. SOHCAHTOA. Those are the big 3, sine, cosine, and tangent. You have buttons on your calculator for sine, cosine, and tangent. You do not have buttons for these. Luckily though, these are the reciprocals of these. And what do I mean by reciprocal? Flip, right? So if the sine is 5/2, excuse me, if the sine is 2/5, the cosecant is 5/2. And if the cosine is √21/5, the secant is 5 over √21. And if the tangent is 2 over √21, the cotangent is √21/2. I am done with one small little thing. Does anybody notice anything about any of these? What? Not supposed to have radicals in the bottom, right? You're really not supposed to. Now, as you grow up and go out into the math world, that's going to become less and less important because your problems are going to get harder and harder. But for now, we're going to go ahead and rationalize our denominator. So anytime we have a radical in the bottom, like right here, we're going to times top and bottom by √21. So 2√21 over 21 is the best answer to that problem. You will do a similar thing with your secant. So it will be 5√21 over 21. All right, everybody okay with that? Remember that rule, the radicals on the bottom? All right, next D is pretty much the same thing. See how far you can get with it. Please do pay attention. Here's theta. Tell me what you've done so far. Maxwell, what are you doing, honey?
Sorry, I was reading.
I know, aren't they awesome?
Yeah.
Those are awesome, but right now we're focused on trigonometry.
Sorry.
Okay, Kara, what have you done so far?
I've been working on the ones that I didn't actually remember how to do, so the sine, cosine, and tangent.
Okay, so what did you start by doing during your picture?
I had to identify all of them.
Okay, so you mean opposite, adjacent, and hypotenuse? So this is clearly the hypotenuse. Theta is here, so what's the 3? Opposite, and 5 is adjacent. Now, is everybody clear on that? Because if you get that messed up, you're going to be in trouble.
I'm not good.
Yes, and you know why you might not be?
Why?
Because you weren't paying attention.
No, I won't.
Okay, no. You had your back to me. Okay, don't mess with old women. Look at where your angle is.
Yeah.
The side directly across from it, on the opposite side of the triangle, is the opposite side.
Yeah, I was looking at like the 90 degree. I thought that's what you meant by the.
No,
Yeah.
across from the 90 is always the hypotenuse.
Alright.
This is the angle you look at. Okay? All right, so Kira, what did you do next? Yes, you identified opposite, adjacent, hypotenuse. Now what?
Then I went and I found the sine, so I did the opposite over hypotenuse.
Okay, but wait, I don't know what my hypotenuse is.
I would have to do the diagram theorem.
Yep. So this time we're looking for the hypotenuse. So 3 squared plus 5 squared equals c squared. So I got the square root of 34. Check my arithmetic. Does that sound right? So then I am home free. Sine, like you said, Carol, will be 3 over root 34. Cosine will be 5 over root 34. And tangent will be 3/5. Then I'll just flip them over. Now, since we're just learning this, guys, I was really nice. I lined these up so they're exactly here. But you need to know, you need to have memorized that cosecant is reciprocal of sine. secant, reciprocal, cosine, and so on, okay? That's, trigonometry is so easy because there's a lot to remember. So we gotta start getting this stuff down. Now, do I need to fix any of these, or are they okay? This one needs fixed. And this one needs fixed. All right, what do you think? Everybody good? All right, let's look at the next one. Now, the next one is different because while the picture is drawn, nothing's labeled in it. And the only piece of information we have is that the secant is 3/2.
Cosine's 2/3.
So cosine's 2/3, that's a gimme, right? They're reciprocals, that's, you know that, boom, points.
The adjacent sides to and hypotenuse is
Exactly. If you know cosine is 2/3, then don't you know adjacent and hypotenuse? Now, look at your picture. This is adjacent, would you agree with me? This is hypotenuse, and this is opposite. So, 2/3, just like Eli said, he's exactly right. Now we're kind of back to where we were over here. To find that third side, we're gonna use our Pythagorean theorem, but we're gonna set it up right. 2 squared plus b squared equals 3 squared. Is everybody clear on that? 3 squared's over there all by itself. So 4 plus b squared is 9, b squared is 5. So my opposite side, I think, is the square root of 5. Now we can fill them in. You can fill them in for me. Let's see. Paige, can you fill them in for me? What's the sign?
Square root 5/3.
Perfect. Which makes the cosecant 3 over the square root of 5. Awesome. Paige, what's your tangent?
Square root 5/2.
Perfect. Which makes our cotangent 2 over the square root of 5. Everybody okay? Let's clean them up. Which ones need cleaned up? Cosecant and cotangent. All right, on your own with your partner, would you try B? 2B with your partner. Now, I didn't tell you this before, so I'm gonna tell you right now. Notice that for 2B, there is no picture drawn at all, right? When there is no picture drawn, you draw this picture. That is your standard triangle in standard position. Draw that one. If they don't draw it for you in the problem, if it's not drawn for you, then this is what you draw. And theta is always the angle at the origin. So if you are left to draw it yourself, this is what you'll draw every single time. All right, now go with your partner, figure it out, and see what you come up with. mistake last period. Do I have any mistakes in here? Does that look okay to everybody? Now, would you agree that this is very simple?
Yes.
But there are some things you have to remember, right? Like what is sine? What is cotangent? So you need to be memorizing as we go. We're gonna ramp it up a notch now. Find the exact value. No calculator. We're gonna find the exact value of sine pi over 3. Now, let's go back to yesterday. Pi over 3 is a radian measure. And I can change that into degrees by remembering that pi is 180. So a third of that would be 60. We are being asked to find by hand the sine of 60 degrees. Pi is 180, a third of that is 60. So I am going to draw, there's no picture, so I'm going to draw that picture. And the angle, before it was unknown, so it was theta, now it's known, 60 is going to go right here. Now, if that's 60 and that's 90, then this one's 30. That is one of your special right triangles. It's on your purple sheet. It needs to be engraved in your brain because the sides of a special right triangle are known. We know that the sides of a 30, 60, 90 are 1, 2, root 3. Now, you don't just randomly put the 1, 2, root 3 on there. The 1 goes across from the 30, the 2 goes across from the 90, and then the root 3 goes across from the 60. No matter where the 30 and 60 are, across from the 30 goes a 1, across from the 60 goes a root 3. Okay? Now, in that triangle, would you agree that this is the adjacent side? Remember, this is the angle that matters, right here. We want at the origin. So that's the adjacent, this is the opposite, and this is the hypotenuse. Would you agree? Now, you only want one thing. You want the sine. What's sine? Opposite over hypotenuse. So the answer is root 3 over 2. Done. How simple is that? Easy. Secant pi over 4. Well, pi is 180. So what's a fourth of that? 45. So now I'm going to draw my exact same picture, but now the angle is going to be 45. And this is also 45 then, right? Whoa, it's another special right triangle?
Yes.
What are the sides of a 45, 45, 90? 1, 1, root 2. Okay, secant. Well, first of all, this would be adjacent, this would be opposite, and this would be hypotenuse, right? Remember, this is the angle that you look at always. Okay, now what's secant? Secant is reciprocal of cosine. So if cosine is adjacent over hypotenuse, then secant will be hypotenuse over adjacent. So hypotenuse over adjacent, root 2 over 1, or just root 2? Oh man, I love math. Okay, tangent pi over 6. Who tell me how many degrees pi over 6 is? 30. How do we know that? Pi is 180. And a sixth of 180 is 30. So here's my picture. Here's my 30, always at the origin. That makes this 60, because this is a right triangle. I already had this one on the board. Across from the 30 is 1. Across from the 90s 2. Across from the 60s root 3. Somehow you must remember that, you guys. Okay? You learned it in geometry. Alright, I want tangent. What's tangent? Opposite over adjacent. So 1 over root 3. Now, I didn't label my sides this time, but would you agree this is opposite and adjacent? So 1 over root 3, which is root 3 over 3. Last one on your own, cosine pi over 3. On your own, figure it out. Cosine pi over 3. Drew, what's the first thing that went in through your head there when you looked at this problem? What?
Draw it out.
Okay, so, but wait, what did you do here first? Didn't you think of something first here?
60.
Yeah, so first we're gonna think of that as 60. So then I know how to draw my picture. Here's the 60. So my 30's here. Hopefully, your labels look like this. We want cosine, right? So cosine is 1/2. Katie?
I'm just confused on where you're getting the 60 at first.
Pi over 3. Pi is 180. You have a video to watch in, okay? Pi is what you learned this yesterday. Pi is 180. 180 divided by 3. Okay. Grab the calculators. We're going to do 2 problems quickly on our calculators. And then that's all that we have time for, unless you just want to stay.
Yeah, we can film next.
All right, I hear everybody not wanting to stay. Okay, it's all right. My self-esteem can handle it. Go to mode. Change your calculator into degrees. Problem number 1 says find the secant of 10 degrees. So our calculator must be in degrees. So everybody find mode, right? Found mode right here. Make sure degrees is highlighted. And now we need to find the secant of 10. Now the very first thing that should be occurring to you at this moment is, I paid $100 and some for this calculator, and it does not have a secant button. And you're right, it doesn't. So what is secant? What do we know? There's no buttons. Secant is the reciprocal of cosine. Secant is the reciprocal of cosine. So you must literally type 1 divided by cosine 10. The only way to get a secant into your calculator is to do 1 divided by.
We have to put a degree mark.
Nope, you don't need the degree mark, because you told the calculator everything you put in was going to be in degrees. Now, if it had minutes attached to it, you would have to put in the degree mark. But if it's just 10 degrees, it's just 10. So, did you get 1.0154? That's your answer. That's the secant of 10. All right, last one. Tangent, 2811. Do I have a tangent button? Yes. So I just press tangent. Whoops, hang on. 28 second angle degrees. 11 second angle minutes. And did you get .5358? On target, all right, don't forget, be working on that 4-1 homework, and I will see you when I see you. You're welcome. Make sure you have a functioning calculator every single day.